between the two meshes. So if you are consider node a mesh A, let's say the current for node A will be positive, but the current through the shared resistance from node B, mesh B will be negative. The same thing if you are doing you are analyzing the mesh B. Okay, all the mesh current around mesh B will become positive, but the current that is shared between the mesh A and mesh B, that the resistor in between the current will be negative, right? So you have that, then you have the mesh analysis in terms of voltage, then you express the voltage in terms of current, and then you solve for the mesh current. So mesh current is usually labeled with ABC alphabet, while the branch current is using numbers 1, 2, 3. And then you see which branch, which mesh, the mesh current relates with which branch and so on. So if the current is, the resistor is in between, so the current of the branch is the product or the sum or the difference between the two meshes and so on. All right, so once you have that, you will be applying that mesh in lesson 4, maybe once a while, to solve your circuit theorem. So now we go the next topic, that is the mesh, circuit theorem. Tengok ni, can you see?
Boleh, sir.
Boleh.
Yeah.
Boleh, sir.
Okay. Circuit theorem. So first of all, in lesson 2, you just solve the circuit with using simple series parallel, because you only have one sources, current or voltage. So it's very straightforward to solve it using mesh of using series parallel or even your star delta. Okay. Then if you have the two sources, you have the mesh or nodal analysis to obtain all the voltage or the current at that particular resistor branch and so on. Right. Now with lesson 4, now is a circuit theorem. So what we'll learn in circuit theorem is much more further than that, where you have to apply both the lesson 2 and lesson 3 into lesson 4. Okay. First, we go by the linearity property. We need to understand a little bit on linear property, then superposition, source transformation, Thevenin theorem, Norton theorem, and maximum power transfer. Okay, we'll go along and I'll explain to you one by one what is the topic is all about. The first thing is the linearity problem. Linearity property. It is just a general idea, so there will be nothing in the in the assessment letter. So this is just a property, okay, that be based for all the other theorem there, superposition, transformation, and so on. So with this linear property, it will be applied to be used in superposition, transformation, and so on. So linearity is the property relationship between cause and effect. The property is combination of homogeneity, additivity, and so on. Ini boleh cerita lah. Whatever it is, you have the input excitation multiplied by apa? The homogeneity property requires that if the input or the excitation is multiplied by constant, the output of the response is multiplied by the same constant. So apa yang dia cakap ni, the panjang-panjang tulis ni, the basic thing you want to say is that you have IR. So if you multiply, the current is increased by a factor of K. The output voltage will be also increased by a factor of K. So that is linear. So it is increased by some factor. The input, the output would also be increased by a factor of K. So the additivity is the result of the voltage or uh, sum of the input that you can this one summarize to become the total of the two voltages. Let's say you say that you know that V1 is equal to I1 R1, V2 is equal to I2 R. So the same value of resistance, only the different value of voltage and current across that resistor. So the voltage will be equal, of course, if you add it up, you have the I1 plus I2R, that is the I1R plus R2I. So you have I1R R2I, that is the V1 plus V2. So the voltage is actually the sum of the two voltage, okay, caused by each of the current. So the resistor is not changing because the resistor is linear. So the resistor is linear element because the voltage current relationship has satisfied both homogeneity and activity. So it can be multiplied by a factor of something, or you can add the two voltage of a resistor of the same resistor with different voltage or different current. So linear circuit is basically if you the property of the circuit is additive and homogeneous, then it is a what we call a linear circuit. So a linear circuit is those whose output is linearly related or directly proportional to its input. So a linear circuit consists of only linear element, dependent source, and independent source. Okay. So you have V is equal to IR, but power is equal to I square R or V square over R. So power is not linear because it is a product of a square. Okay, I square V square. So it is a quadratic function in real term. It's called the quadratic function. The relationship between power and voltage is non-linear. So power is not related linearly with the power. Power is not related linearly with the voltage or current because it is a factor, a quadratic function that is I square and V square. Therefore, theorems covered in the lesson are not applicable to power. So when you want to do the power, you cannot use the linearity property, meaning to say you add P is equal to P1 plus P2, that is I2 square, I1 square plus I2 square R. You cannot do that. You have to do individually for the power. Okay. So you have whatever the circuit there inside here. So consider the linear circuit shown. A linear circuit has no independent source inside it, directed by voltage source that serves as input, implemented by the resistor RL that serves as a load. So basically apa dia kata, you have voltage source, you have linear circuit containing only of linear element, that is the resistors only. Okay, no independent source, so just a linear circuit element with terminated by the output RL. We may take the current IL through RL as the output. So if we do that, if we have, suppose that according to the linearity property, if we have Vs 10 volt, IL will be 2 milliamp. Similarly, kalau you ada Vs 1 volt, basically in proportionality. So 10 to 1, so 2 to 0.2. So 1 volt will give you to 0.2. Kalau 5 volt will over must give you IL is equal to 1 milliamp and so on. So IL is equal to 1 milliamp must be due to the Vs is equal to 5 volt. So now here you said an example to apply the linear property. You are the I naught here. So what is the I naught when Vs is equal to 19 and 38 respectively? So how you do this according to linearity property? So you just find the relationship of the I naught. So if you do all your mesh analysis, okay, I'm not going through this because apa ni ini just lesson 3 punya part. Okay, you apply KVL around IA, you apply around IB, so you have two equation there. Only that kat sini ada silap sikit. If we look tak, bukan yang ni. If you look there, so you have the relationship between I naught and VS is equal to I naught is equal to the IB. So you see there. So we assume IB, okay, the mesh analysis IB, the current IB for the mesh is actually the I naught. So I naught is actually IB is VS over 676. So for when VS is equal to 19, I naught is 0.25. So VS is to 38, the I naught will be increased because the voltage is double, the current will be double. So that is just a simple example on the linearity property. Sama juga yang ni. You use linearity property by assuming the output and what is the input. What happens here is that you have IS there and you want to find I naught. You don't have to find the I naught, the actual I naught. You just assume I naught to be some value and then you see what is the actual value of I naught. So basically apa dia buat kat sini, kalau you go through the solution later, assume I naught 1 milliamp. What would be the IS? Okay. So if you do that, kalau you tengok sini, you assume I naught is equal to 1 milliamp. So you go back, you go back, you go back, you go back, and then lastly, you'll get your IS to be 5 milliamp. So here it is given I naught is equal to 15. You assume I naught is 1 milliamp. Okay. But if you calculate your I naught is equal to, you assume I naught is equal to 1 milliamp, your IS is 5 milliamp. So basically, if IS is 5 milliamp, but your actual source is 15 milliamp, that is, of course, by linear property, it is the IS must be IS is 3 times the value of I naught that you assume 1 milliamp. So 3 times I naught. So I naught of 3 milliamp only then will give you 15 milliamp. So this is basically what is the property, linear property is all about. So tidak ada apa yang perlu kita buat specific question on assessment. Is just a matter of using your linear property. Once you assume some value and then assume some value of the output and see what is the input, okay, and then the actual input will actually relate to what the output is and so on. Okay, so macam gini contohnya. Alright, the same example there. Find V3 from the practice problem when IS is to 15 milliamp and IS is 30 milliamp respectively. So what you have to do is that you need to find V3, relationship of V3 in terms of IS. So you can see that the IS, okay, value for the two current given 15 milliamp and 30 milliamp. So sama juga yang ni, using linearity, okay, assume V3 is equal to 1 volt. So you assume here 1 volt, okay. And then you go back, you find what is the cost of the V3 1 volt to be from the VS. So kalau VS is equal to something value, in this case, what is that? So maybe some value, okay, let's say 60 volt. So if it is 60 volt, so the V3 should be 2 volt and so on, right? So the linearity of the input and the output. So if input is increased, the output will also, the output is increased, the input will also be increased by some factor as what we said just now, K. Right? So itu saja, yang itu yang akan digunakan for the next one. This is the thing one part of the very important part of the this lesson. Apa nama the theorem that involved in what we're going to learn. So mula-mula sekali kita ada superposition. Superposition, okay, you can read all this one is about the idea of superposition rests on the linearity property. So basically, the superposition says that if you have the a circuit with many sources, okay, the particular voltage or current through an element in the linear circuit will be equal to the sum of the voltage or current through it by considering one source at a time, or in what's that, in words, the superposition principle states that the voltage across or current through an element in the linear circuit is the algebraic sum of the voltage across or current through that element due to each independent source acting alone. So kalau you ada 3 sources kat circuit tu, you can consider one source at a time, and then you find whatever you want to find at that particular branch. Katakan you want to find the voltage or the current, so you do that. So one source, okay, you consider one source and then you find the voltage or the current. What about the 2 other sources? We off it. So let's say we have 1, 2, 3. We on only V1, then we off with 2 and 3 and find whatever voltage or current. Then we move on. We on only the number 2 source and off the 1 and 3 sources, and you find what is the voltage and current. And finally, you find you on the only the 3rd source and you off the 1st and 2nd source, and you find whatever current and voltage you want to find. Once you have that, you have all the 3 variables that you want due to each of the independent sources. So you add it all together, right? So the principle of superposition helps us to analyze a linear circuit with more than one independent source by calculating the contribution of each independent source separately, so one by one. To apply the superposition principle, 2 things must be kept in mind. We consider one independent source at a time. As I said tadi, one only. All the others are off. Macam mana kita off? The voltage must be 0. How do we do the voltage source? I've already mentioned so many times. How you want to make the source 0? We apply a short circuit, because for a short circuit, there is a current, but there is no voltage. Okay? Or you can off the current source, okay, making it 0 by open circuit. With an open circuit, the current cannot flow through, so the current will be 0. So remember now, if you want to off voltage source, you short circuit it. You want to off the current source, you open circuit it. So that's the 2 main things that you need to remember, and you need to memorize. And then with that, you will have a different combination of circuit. That is where your series parallel or whatever comes into play. Kalau you tidak faham lagi series and parallel, you'll get a circuit nanti. You cannot see which one is series or parallel or so on, and you cannot do the question. You cannot solve it. And one more thing, okay, you cannot combine whatever voltage or whatever resistor that you are going to find the current or voltage, because if you combine, your resistor, your branch will be lost and you don't know what is the value that you want to calculate. So remember, jangan usik yang resistor di branch yang kita nak calculate. So dependent source, we have last time, dependent source is what? We are current apa? PCVS CVCS and so on to voltage control, current control, voltage source or current source. So they are left intact because they are controlled by some other circuit variables. So kalau you ada dependent source, you cannot off it because it is dependable on the other element of the circuit. So I won't give you something that is that difficult. It will be all independent sources. So it makes your life easier supposed to be. Right? So apa kita nak buat? Macam tadi, hari tu kita ada 3 step juga. Tak banyak. Semua ada 3 step. Kalau KW apa ni? Nodal analysis. Okay. Label all the node. Okay. And one node is the reference and the other nodes are non-reference. And then you apply KCL at that node and then express the current interval voltage and then solve for the voltage node voltages using the matrix. Sama juga yang ni step ada 3. First of all, turn off all independent sources except one. Okay. Kalau off semua sekali tak adalah you nak buat apa. And so you off only all except one. So that is the source that you're going to analyze. What is the output of the current or voltage at that particular branch or element. So find the output voltage or current due to the active source. So repeat step 1, meaning to say you do that one by one. Step 1, off one, analyze the other, off all except one, you analyze, and then you off all the others except one of the next one, and so on. The next one, okay, on, all the other off, and then the next one, let's say source 1 on, others off, source 2 on, others off, source 3 on, others off, and so on, until all the sources are already been used, been analyzed, and then find the total contribution by adding algebraically all the contribution to the independent source. So you have, okay, all the values due to each of the sources, and then you sum it up together. And also remember that later you'll see that the contribution of the voltage, the combination of each sources will give you the voltage or current, maybe different polarities. So if it is different polarities, although it said adding algebraically, but actually you are going to add using positive and negative. Let's say one is going up, one is going down. So it is basically minus the 2 and so on. Right? So ini semua tak ada apalah. Apa analyzing circuit ni theoretical lah. Analyzing circuit using supervision, one major disadvantage, it may very likely involve many more works. Of course lah, you can solve one by one. However, supervision does help to reduce complex circuit to simple circuit, to replacement of voltage source by short circuit and current source by open circuit. So you ada banyak sources, you can replace all but one sources with short circuit on open circuit. So keep in mind that superposition is based on linearity. It is not applicable to the effect of power due to each sources, because the power absorbed by resistor depend on the square of the voltage or current. If the power value is needed, the current through across the element must be calculated first using superposition. So nanti you akan dapat katakan voltage or current, you cannot use that value to find the power. Okay, you have to the power you have to find, okay, using each individual contribution of the voltage or the current. You cannot use the sum to find the power. You have to use one by one the power, or for the current and the voltage, using the value of the voltage or the current. Okay. So far so good? Boleh kot?
A lot of information.
Okay, sebab tadi banyak teori saja. Sebab mungkin you tidak faham. Okay, bila kita buat example nanti you nampak. Okay, superposition. Dia kata apa? One on, the other off. Okay, that is the most critical or the most core thing that you need to remember. You ada superposition, you ada banyak sources, on satu, off satu. Okay, so now you have the first thing that you need to define what are the voltages. Okay, dia kata for the circuit in figure 4.62, find V2 using superposition. So V2 using superposition is that you find V2 due to Vs only, and then you find the V2 due to Is only. So V2, it will be the sum of two voltages due to Vs and Is respectively. So you need to define the V2 is equal to V2A plus V2B. Okay, that is question 4.31. And then you define what is V2A due to 6 voltage source, and what is V2B due to Is is equal to 3 milliamp current source. Ini you kena tulis. Jangan you tidak tulis sebab nanti, okay, I cannot understand, I cannot read your mind. What are you doing? So, kalau you complain kat sini, every time, jangan skip this part. You need to you need to define V2 is equal to sum of the two V2A dengan V2B. What is V2A due to Vs? What is V2B due to Is? So you have to define. So once you do that, you see this circuit. Okay. Vs. So V2A due to Vs. Okay, what you do? You consider Vs. What we're going to do with Is? Anybody? Kalau kita consider Vs, apa kita nak buat dengan Is? Yeah, how do you turn off it? How you want to turn off your Is?
Open circuit.
Yes, okay. That is the only thing that you need to remember. Now you have already identified V2 is equal to V2A plus V2B. So you need to analyze due to Vs or Is. So as is stated there, kalau you nak turn off current, you open circuit. Kalau you nak turn off voltage, you short circuit. So tu saja yang the next step that you need to remember. So now you say that, okay, to find V2A, open circuit Is ataupun turn off Is, meaning to say you open circuit it. So to find V2A, turn off the 3 milliamp current source. That is what you do. How you want to off it? By open circuit it. So once you open circuit it, meaning to say that this part of the circuit open, so it is just a dangling hanging wire, so we boleh buang. So that will give you from 46A, okay, where the current source is open circuit, okay, because you want it to be 0, so you have this circuit for 6B. So from there you can find, of course, your V2A. Okay. Yep. Okay. So yeah, there are two ways to solve the how you want to find V2A. Of course, the first one is the direct method. You can see from the circuit, you can apply voltage divider rule, VDR. VDR says that the voltage across that resistor is equal to that resistor value divided by the sum of the two resistors in series multiplied by the source voltage. So that V2A is the voltage of the R2 divided by R1 plus R2 multiplied by Vs. So you have plug in all the values. So you have V2A, the voltage due to Vs only is 2 volt. So either way, you can also use the current to find the V2A. So this is a bit longer. So you can see which one is easier for you. So you can do, you find the current and then you multiply the current with the resistor, you'll still get the same value of V2A. So this is simple circuit because just buang satu part, tinggal series circuit. Okay. Nanti kalau lama-lama nanti you have many other elements, so you find it a bit complex the circuit and you need to see carefully apa yang akan jadi series or parallel and so on. So we go back on the circuit, on the original circuit. The next thing is you want to find V to B. What is your V to B? Due to IS alone. So you only due to IS. So you want to off VS. What happened here, VS?
Short circuit.
Short circuit. Okay. To turn off water source, short circuit. Okay, good. Okay. So kalau you short circuit sini, can you see what's going to happen to the circuit? So what happened now? Okay. What happened?
VS equals to 0.
Of course. Itu tak payah cakap. Itu dah memang tahu dah. VS is
Okay.
equal to 0 short circuit, maknanya straight line saja. That is apa obvious. But I want to know what happened to R1, R2 dengan IS tu. How does the circuit look like? And how are you going to find V2B now with the VS gone? With the VS gone, short circuit, meaning to say there's no VS there. So the R1 will be actually
Parallel.
parallel dengan R2. So how are you going to find V2? You need to find the current through R2. How do you find the current R2? You apply KCL because you have current in the node branch off into R1 and R2. So you can see that short circuit, okay, memang kat sini 0. Okay, that is obvious. But the thing is that you want to find V2B. How you want to find V2B if you have this circuit? So what you do is that you redraw the circuit, only then you can see that R1 is parallel with R2, and then you have a source current IS. Obviously that you can find the V to B if you know I to B. How you want to find I to B? Okay. So mungkin dekat nota you kalau you tengok, kat sini dia tulis apa? I apa? I2 saja kot. That's it. Can you see your this one? Not your slide? Kat sini dia tulis apa? I apa? I2 saja kan?
Yes, sir. Yes. I2 only.
Okay, betul kan I to B. Sama juga dekat sini, dekat sikit sini, dia tulis I2 saja. Betul tak? So you letak I to B. You can put also I2, no problem. So you know that I2, I1 and I2, but you just want to be specific. It is I to B because this is V to B, so the current is I to B. Okay. So now you have that I to B is you apply a KCL, I, because that branch is equal to the other branch divided by the two branches in parallel multiplied by the current that is entering the node of the two branches. So if you remember that, you don't have to remember R1 over R1 plus R2, R2 over R1 plus R2. Just remember that the other resistor divided by the sum of the two resistors in parallel multiplied by the current source that is entering. So you can see that I to B is the other resistor R1 divided by the sum of the two parallel R1 plus R2. multiplied by the current going in, that is IS, so you have the 2 milliamp. So now you have 2 milliamp, I to B, of course you can find the V to B. So V to B now is 8 volt. So V to B is due to the IS alone. V to A is due to BS alone, which is 2 volt. So kita put this saja. So the V2 is 10 volt. Okay. So that is what superposition is all about. So kalau you buat ni, okay. If you want to do the normal analysis, you can try to do it as a practice and see whether you still get your V2 10 volt. Okay, just to prove that the linear property works. Okay, so this one is a very simple circuit. Kalau circuit macam ni, ada 3 sources, ada 2 voltage source, ada 1 current source, and you want to find that particular I4. Okay, so what are you going to do? So first you need to define I4 is due to 3 sources. So we call it I4A, I4B, I4C. Okay, remember, define to dulu. What is I4A? You can say I4A due to any of the sources. I4A can be due to IP, I4B can be due to VP, I4C can be due to VQ or whatever. But usually you start from the first source on the left lah. Lagi senang nanti you nak trace. Kalau tidak you cakap ni dulu, ni dulu, ni dulu, nanti complicated kan. So just consider the left source first and move along to the right. Macam kita buat tadi, macam itu kita buat apa? Right down kan, so we go right. So whatever source we see from the right to the left, from the left to the right, you consider it as A, B, C first. So in this case, 4A is due to VP, 4B due to VQ, and 4C due to IP. Okay. So apa kita buat sekarang?
You turn off the source one by one.
Pardon?
You turn off the source one by one.
Yalah, that is the law. Tapi sekarang yang penting sekarang ni, that is the theorem. The important thing is how does the circuit look when you consider each and every one of it alone. Okay, what you need to do? You need to define. To find I4A, turn off VQ and turn off IP. You have to write that. Turn off VQ. What happened to VQ? Turn off. You buat 70262 ni siapa ni ya? Siapa nama? Einstein. Einstein? You never answer me. Mesti tak pernah. Kalau saya panggil tak pernah jawab pun. Andrea. Andriana. Ada tak? Alicia. Oh, Alicia.
Yes, sir.
Ada pun. Andriana. Ada nama ni. Mana kita?
Here.
Ada. Okey, apa? If you want to consider VP, you off VQ dengan IP. Apa, macam mana you off VQ? The two of you. Jawab sekali. VQ you buat apa?
Short circuit.
Okay. IP?
IP open circuit.
Okay. So VP, now you have the I4A. Okay. So you dah cakap je short circuit, open circuit. Macam mana rupa what the circuit will look like? Generally saja. You can imagine VQ short circuit, What happened dengan R2, R3, of course, when IP is also open circuit?
If VQ short circuit, then macam imagine VQ tak ada, so straight line continue to R2.
Okay, so what happened then?
What happened? Maksud VQ tak
Apa
ada?
jadi lepas tu? Bila you short? Okay, sekarang you ambil pen and paper. VQ
Okay.
tu you short.
VQ short. So maksudnya
You can erase it lah.
uh-uh.
Erase it, you replace it with a short. Apa ni, just connection between the two lah. Straight line aja lah. Betul?
Betul.
Okay, IP buat apa? Open circuit.
IP open circuit.
So basically, kalau open circuit, what happened to this wire?
Hilang.
this wire? Gone.
Yes.
Betul? So
Betul.
with that, what happened to R2 dengan R3?
They're in series now because boleh sambung.
Okay, good. Alright, you tidak payah explain. You nampak saja tu dah tu. Okay?
Yeah.
So this is technical. The thing is that from the circuit, nama pun circuit theory, you know pun R2 dengan R3 is series. And what is the relation with R1?
R23 is parallel to R1.
Yes. So what is that? That is what I want to know. You tengok sini. You have to know the circuit. How does circuit looks like? So find for A of VQ of IP. So VQ is replaced by a short circuit, just a connection wire, and IP is an open circuit, so you can throw away all the wire kat sini actually. Okay, kalau you buat lab pun you ada apa ni hanging wire saja. Buat apa kat sini? Buang saja. So bila you buang sini, you nak cari yang I4 kat sini kan? So I4A, so you can see that 2, 3 is in series, which is then parallel dengan 1. So with that, so if you do that, you have a circuit which is very much more simpler. You can find the I4A. You find that I4A is equal to VP divided by R1 to 3 plus R4. So you need a circuit. You tidak boleh. You just imagine, you just sketch, you just scribble. But in the end, you need this proper circuit. Only then you can find the I4A. Kalau dia tak ada circuit ni, you just imagine macam ni kan. So you cannot find the answer. You need pen and paper. Every time, apa akan jadi? You short circuit, open circuit, all the other sources. Okay, that's why I say to you, the series parallel is now very important because you can see that R23, kalau you tidak faham lagi, you ingat R23 parallel and so on. Okay, ada yang buat nanti R13 is series, macam-macam lah. I have already experienced this, macam-macam theorem yang you buat sendiri. Okay, theorem you sendiri, undang-undang you sendiri. You suka hati je nak buat yang mana series, suka hati aja nak buat yang parallel. You just define saja which is wrong. Right. So now you can see 2, 3 in series. So what is the value? R plus 4 is 12. 12 now parallel dengan 4. 12 times 4 is 48. 48 divided by 16 is 3. So very simple. So you can see that R123 is 3. So I4A VP is divided by R123 plus R4 divided by, I4A is VP divided by R123 plus R4. So you have 2 milliamp. So remember, I4A is due to the VP alone. That is value is equal to 2 milliamp. So keep that one first. So the next one is VQ. Due to VQ. So due to VQ, what happened now with VP and IP? Alvin.
Yes, sir.
Yeah? What happened now? You consider VQ, that is the V to I for B. What happened to VP dengan IP?
VP is short circuit and IP is open circuit.
So how does the circuit will looks like basically or roughly? Whatever lah. Okay.
For IP, the wire is gone on that part.
Yes, of course.
After that, for VP is just a
Short circuit.
normal wire connection over here.
I mean short circuit just a connection only lah. There is no.
Yes.
Okay. So if you imagine that, if you do that, what happen now? So you have some circuit like this. Short circuit here and open circuit here. So meaning to say that again 2, 3 is parallel, sorry, it's series, 2, 3 series, and then you have R1 in between it, and you have your R4. So you see this circuit, you want to find what is I4B. How are you going to do? So the only thing that you can do is that you apply mesh analysis. Okay. So what you do is that you apply a mesh analysis. You have the I1, IA. Okay. Oh, sorry. If you go around that, you have VQ plus R2 plus R3 plus R1 IA and minus R1 IB. So you have that equation R1 plus R2 plus R3 IA minus R1 IB plus VQ. So you do that, you have one equation IB in terms of IA is equal to 4IA plus 6. Why you are interested in IB? Because IB is actually the current of IB. So you need to find IB. So if you apply around loop IB, so if you apply around a loop IB, so you have the R1 plus R4 IB, but minus IA R1. So minus R1 IA plus R1 plus R4 IB. So you have the IA in terms of IB. So you can substitute IA in the equation of IB. So you have your IB is equal to minus 1 milliamp. So basically I4B according to the circuit is actually IB. Now you have, as I said to you, it might be positive, negative. Now you have a negative. So remember, when you add on, nanti you need to minus it, not plus. So maybe you said 2, tadi kata kita dapat apa? 2 campur bracket minus 1. Okay. Then you can see it's 2 minus 1 for the IA and IB. What about the IC? I4C is due to the IP. So apa akan jadi circuit ni? Apa lagi? The next one. Amisha.
Yes, sir.
Apa jadi?
Both
Circuit.
will short circuit.
Yes. Okay. What will happen to the circuit?
Just a straight line for VQ and VP.
Okay. And then apa lagi? Sebab you nak cari I4 tu. Macam mana? Apa akan jadi dekat circuit tu? Kalau you tengok betul-betul nanti.
R2 will parallel with R1 and R3.
No. Itu yang saya kata tadi. Ini yang saya akan jumpa. Okay. Yang tu tadi dah betul. Sebab tu you kena draw dulu. Okay. You draw tadi, you imagine saja. Tapi you draw, you tengok betul-betul. Okay. Short circuit kat sini. Short circuit kat sini. So macam mana you kata R2 parallel dengan R1 dengan R3. R1 dengan R3 ni tidak boleh series, tidak boleh parallel sebab ada node kat sini. So you have to see the circuit dulu betul-betul. Baru you can see. Okay. That. Alright. Okay. So you can see that you ada circuit macam ni. So you akan nak cari 4C ni. So how are you going to find the 4C? So this is the only way. That is what way? Nodal analysis. You draw sini baru you nampak bukan series parallel. Okay. Ni bukan soalan saya. Kalau soalan saya, ya senang. Series parallel and so on. Tapi soalan ni dia just example. So you just want to show you all the mix of things that you need to do. You can use series parallel, you must use KVL, KCL, you must use mesh nodal analysis or nodal analysis. In this case, you use nodal analysis. So what it says that, okay, KCL and Ohm's law at VB. So dekat VB kat sini apa? VB is equal to I3 is equal to I1 plus I4C. I3 is equal to I1 plus I4C. So what is I3? VC minus VB. You tengok sikit lah, saya malah bagi balik. Okay. IC is equal to VC minus VB divided by R3. I1 is VB minus VA over R1. And I4C is VB minus naught. So you have there an equation showing you that relationship between VC and VB. And then you apply again KCL and Ohm's law at VC. So at VC there, what you can see, note VC, IP is equal to I2 plus I3. So you can see that IP is equal to I2 plus I3. IP is 3 milliamp. So I2 is VC minus VA over R2 and I3 is VC minus VB over I3. So you have another equation, okay, a relationship between VC and VB. 24 is equal to VC minus 3 and so on. So that is the only node that you need to analyze because you want to find I4. So you don't need to analyze the node VA sebab tak perlu. Okay, you perlu I4C saja. That is already, you can solve it by knowing VB and VC saja. So you know that VB and VC, so you manipulate the V2, the 446 and 447. Alright. So you can see that ini pun ada silap sikit Sepatutnya 24 is equal to 10 VB minus 2 VB. Okay, sebab kita dah replace VA dengan VB tu. So betul kan kat sini? 24 is equal to 10 VB minus 2 VB, which is actually betul dah kat sini. Cuma kat bawah ni saja saya tulis VA. Actually, it is VB is equal to 24 over 8. That is VB 10 minus 12. 10 minus 2 is 8. So 24 divided by 8 will give you 3 volts for the VB. And now you know that I4C is VB divided by R4 ataupun you kita dah buat tadi, I4C is VB minus 0 divided by R4. So VB minus 0 divided by R4. So basically VB divided by R4. So we have 1 milliamp. So this is positive. So now if you sum up together using the superposition, I4 is equal to I4A plus I4A plus I4C. So 2, tadi I4B is negative, minus 1, and C is positive. So 2 minus 1, 1 plus 1, 2. Okay. So that basically covers your superposition that you need to know. Okay, kita ada 2 kat sini. Okay, jangan, to test that you really understand, jangan lupa buat. Jangan tak buat, okay? You need to do. Okay? Once you do this, then only you know that you will understand that. Because yang ini, you won't have the specific question on this superposition, but you have a question applying this superposition, because later on kita akan belajar pasal source transformation. So you have two method, superposition atau source transformation, and then we learn about Thevenin and Norton, and then we combine everything to give you one question. Meaning to say that Thevenin using superposition or source transformation, Norton using superposition or source transformation. Okay, so you need to know the basic thing first, the superposition, and then only we can move on to the source transformation and so on. So source transformation is very straightforward. Saya bagi buat sekejap lah. Oh, you want to break now? You want to continue or break?
Break kejap sah.
Okay, break. Alright, so
Thank you.
5 to 10 minutes. Nanti kita buat sound formation. Okay. Alright.
Alright, thank you.
Okay. See you. Okay, boleh start balik?
Boleh.
Okay. Boleh semua sekali? Okay, now we go to source transformation. So what is the source transformation do? Is that, of course, source transformation. From the word, you know that you have a source, you can transform it to another source. So the only source that we are dealing now is current source and voltage source, meaning to say that you can transform the current source into the voltage source or vice versa, voltage source into current source. So if you have a current source, you transform it into a current source. You have a current source, you transform it into a voltage source. When does the transformation happen? When you want to combine the sources. Okay, you cannot combine voltage and current source together, so you need to make the source to become the same, two same sources, two same voltage source or two same current source, then only you can combine. So this is the source transformation is all about, to help you to combine sources. Right. So how do you combine? So remember that the voltage source will always be in series with the resistor, so that it can be able to be transformed into a current source in parallel with a resistor. So voltage source series dengan resistor, current source parallel dengan resistor. So this is the basic diagram of the transformation of the independent source. Voltage source to current source to voltage source. Voltage source in series with RS, current source in parallel with RS, and the value of RS will be equal to each other, whether it's either current or voltage source. The resistor RS will always be equal. So what you have here, okay, source transformation is the tool for simplifying circuit and so on. You can read that one. A source transformation is the process of replacing a voltage source Vs in series with a resistor Rs by a current source Is in parallel with a resistor Rs or vice versa. So basically, all the summary there is that Vs is equal to, if we have a current source, we want to transform it to a voltage source, that voltage source is given by multiplying the current source with the resistor Is Rs, or if you want to transform the voltage source into a current source, okay, the current source Is equivalent to the voltage source divided by the resistor that is in series with the voltage source Rs. Either way, the Rs will be equal. Same value. Rs, no problem, the same value, only Vs and Is is interchanging. What is Vs? Is multiplied by Rs. What is Is? Vs divided by Rs. So basically, what is Vs here? Vs is equal to IR. Is Rs. So if you have your Is, from where you want to have your Is from the voltage source Vs and Rs. So Is is equal to Vs divided by Rs. You can see there. Okay. So just using the equation 4.5, you can transform from one to the other. Sama juga kalau you ada independent voltage source or current source, it can also be transformed the same theory. Okay. Dependent voltage source in series with resistor, dependent current source in parallel with a resistor. Okay. So all this one theory tak payahlah saya tak explain apa ni. Just to say that it's not possible when Rs is 0, and sama juga current source, it is not possible when Rs is to infinity. Rs is 0 meaning to say short circuit and so on. Alright, so you need to, the Rs here, okay, must be of some value. It cannot be infinity or it cannot be 0 for voltage and current source respectively. Itu teori sajalah. When you are not going to encounter that part. Alright, later. So you can see that one example, straightforward example, okay, is this. Okay, you have two sources, one current source, one voltage source, and you want to find the voltage across V3 there. So you want to see, basically, you want to combine the two IS into VS. Apa kita perlu buat? Okay. Anselm, I think you can answer this. How you want to do? You want to transform the IS into voltage source? Ataupun you want to transform the VS into a current source? So you need to think a bit. Okay, I give you 1-2 minutes to think. Jangan tengok answer. Kalau tengok answer maknanya you tipu diri sendiri. Okay, you tidak belajar. You cuba solve deh. Sebab tu saya punya example semua ada solution. Solution is on the other page so that you can try yourself. Macam mana kita nak buat ni? Untuk combine IS dengan VS. Anslam? Are you there?
PS to current.
Any idea? Okay. Tengok sini kan. Macam mana kita nak combine ni? This one, voltage source, you cannot combine because ada resistor kat tengah ni. But, if you see, kalau you... Alamak, tak suka ni. Just imagine, you ada ni. You transform the R4 into resistor dengan current source ni. Okay. Right. So you can see polarity dia negative to positive, the current source must be going up. Jangan terbalik, okay? Jangan terbalik. So once you have that, the V3 sini kita tidak usik. Okay. So dekat belah kanan ni kita ada current source dengan resistor. Tetapi kita ada resistor R2 sini. So what you need to do, okay, if you imagine you ada positive negative voltage source. Okay, so you transform it, you have a resistor there, and then you can combine with R2, betul? R2 here. So then you combine these two, maknanya, oh, sorry. So if we have the idea there, that is good already. So you ada R2 sini, katakan we name this voltage source VA and the current source here, the resistor of the voltage source RA. What will be the value of VA? That should be straightforward. Berapa value VA? Aslam? V is equal to IR. I berapa?
3 milliampere.
R?
3 milliamp.
R.
R.
Yeah.
4 k ohm.
4 kilo. So 3 milliamp 4 kilo ohm. So your VA should be 12 volt. Betul?
Yeah.
According to the source transformation lah. What is the value of RA? Ashley? Ashley?
Yes, sir.
Berapa? Value? Vs is equal to ISRS. So in this case, VA, kita lama dia VA is equal to ISR1. 3 times 4 kilo ohm. Then in this case, Rs is equal to the Rs of the current source, tapi kita namakan dia Ra. So kalau you compare that, what is the value of Ra?
4 kilo ohms, sir.
Yes, very straightforward. 4. So kat sini 4. So sini 4. Okay. Okay, can you combine with the R2 now? 2K? Because they are in series now. Kalau you combine tu. RA dengan R2 ni. You combine, you dapat berapa? Total semua sekali. Berapa? 6 kilo ohm. Betul? Betul? Izzat?
Betul.
Ya?
Betul.
Okay, so now, you dah tahu sini. So, kita dah transform VA ni. Dan kita ada resistor. Kita dah combine RA dengan R2 tadi. Kita namakan RA2. Sama dengan apa tadi? 4.26 kilo ohm. So with that, can we transform again to a current source? Apa akan jadi kalau kita transform ke current source? Kita akan ada, okay, this current source. The voltage is going up, so kita go up. So now kita go alphabetically lah. So ada VA, so kita panggil dia IB. IB. And RB. Okay. What is the value of IB? Beverly?
Six kilo ohm.
Yeah?
6 kilo ohm, sir.
IB.
Oh, IB. Okay.
Hmm.
IB kita guna formula itulah.
Apa dah?
I equal to V over R. So
Okay.
12 bagi 6K.
Bagi berapa? Berapa bagi 6K?
12 volt.
Okay. 12 volt bagi 6K. So, you dapat apa? Takkan tu pakai kalkulator juga. 12 bagi 6.
2 mili.
Lama je
ampere.
jawab. Bukannya boleh jawab je terus. Tak payah pakai kalkulator. This one is 6K. Betul?
Betul.
Now you have something like that, and now you have the R3. R3 you cannot touch because we are going to find what is the voltage V3 across the R3. And dekat sini, on the other side tadi kita dah transform. Kat sini kita panggil dia, namakan dia C pula. RC. RC dengan we transform the voltage source into a current source. We call it IC. What is RC? So the current IC is going up because the polarity of Vs is going up. So berapa value dia? Anybody? Siapa nama lagi? Carlos, dah Carlos, belum? How do you get 6 kilo ohm? You tengok kat sini. You nak transform this. What is the value of RC? Kamen. Tengok balik circuit you tadi. Dia kata apa tadi? Tengok balik circuit 4.10. And tengok equation 4.5. R for the voltage source is equal to R to the current source. In this case, R of the current source, RC, must be equal to the R of the voltage source. Berapa? Kamen.
6 I of the voltage source.
RC.
Oh, I see.
Ni RC kat sini ni. Kalau you transform this part, okay, this part kepada this part, kepada this voltage kepada current source. What is RC?
6 kilo ohm.
Mana datang 6 kilo ohm? Ada tak dalam
Because
circuit ni 6 kilo ohm? Apa ada kat sini?
R4
Berapa kilo ohm? Tak nampak kan? Alpha tu berapa kilo ohm?
R4 3 kilo ohm.
So mana datang 6 kilo ohm? VS transform kepada IS. RS in series, RS in parallel. So these two value must be equal. So tadi you punya circuit, you ada this part. You ada something like this. Cuma dia terbalik sajalah. VS letak belah kanan, RS belah kiri. So VS, you transform ke current source, must be, RS, you transform kepada current source, RS ni must be equal to the RS of the current source, which is, now, tadi kita dah nampak, it is R4, okay? Which is 3 kilo ohm. What about the IS? IS is equal to the VS divided by RS. Kalau you nak transfer daripada kepada voltage source, daripada current source, it is IS RS. Very simple voltage Ohm's law equation. V is equal to IR, R is equal to V over R. Just transform it like that, the resistor will remain the same. So you can see that over there, RC is equal to R4 and IC is equal to VS divided by R4. So 12 divided by 4, 12 divided by 3, 4 kilo ohm. So kalau you tengok sini, okay, dia transform terus kat sini. Okay, the part for the 3 kilo ohm and 12 volt voltage source, and for the part here, okay, mungkin polarity saya salah tadi lah, sebab current dia ke bawah, so voltage source pun kena ke bawah lah. So the voltage source ke bawah, so the current must be ke bawah. So terbalik, so bila you campur balik, now bila you campur balik, okay, VA dengan RA2 tu, so you can do this, and then from there you can transform the VA dengan R2 to another current source. VA dengan R2, you can transform into a current source. So now with that is the usefulness of the voltage source transformation. Now you can combine the two sources where initially it is current and voltage source. Now you have transformed both two into a current source. You can combine the two, and RC and RB can be combined together. So you combine together, so you have a simple circuit like this. So a simple circuit with IB and RBC, IBC with RBC. IBC is the resultant of the combination of the two sources initially, which is the IS dengan VS, and then you have the RBC is the combination of all the resistance, and now you can find the V3 easily by finding the currents here using CDR, and then you can find the current I3 using CDR, and then you apply the voltage. So very simple voltage source, voltage to current source transformation. So you have voltage source, okay, which is always equal to, which is always in parallel with the resistor Vs, which is always in series with a resistor Rs. You can always transform the source of the voltage here into a current source, but now the current source will be in parallel with the same resistor Rs. Itu saja. There is no fancy theorem, very fancy equation on this. It's just straightforward. So the Rs is the same value for the current on the voltage source, and the voltage source comes from Vs using the basic Ohm's law, with this I S Rs. V is equal to IR. Okay, itu saja. And then the IS comes from the, okay, tengok polarity, the positive, negative, so the current source must be also going up. Kalau polarity dia positive, negative, positive, your current source must be going down. The polarity of the two must be the same, right? So kalau dia ke atas, kalau ke bawah, ke bawah. So positive, negative. So what is VIS? So I is equal to V over R. What is V in this case? Is the voltage source Vs. What is the resistor? Is still the Rs. So the Rs is the same value. It doesn't matter. This one is R1, R2, R3, R4. This means peak, VP, VQ, VR, VS, VT, whatever name. But the important thing is the resistor is the same for the current source and the voltage source in series, the current source in parallel, while the voltage, okay, will be equal to the current multiplied by the resistance, and the current will be equal to voltage divided by resistance. Ini saja. Draw ni ingatkan sampai bila-bila. Dalam exam nanti masuk aja exam, terus draw ni. Supaya tidak terlupa. Just draw this. Belum orang cakap apa-apa lagi, draw, scribe dekat soalan tu. Scribe dekat nota and so on. Sekarang ni you buat sebab tu saya nak you buat on the computer, on your camera, because I want to see what you do. Sebab dulu pernah kita orang tangkap ada nota ada kursi sebelah ada nota. So that is plagiarism lah kalau ikut betul-betul. Right, so this you have. So you tahu dah macam mana nak transform. So sama juga sekarang ni, the same thing. Okay, you want to find V2. So V2 you cannot touch. Remember that V2 do not touch. So what you can do, you can transform this. Okay, basically kalau you nak transform, what you can see is that if you transform these two, what you have a resistor and a voltage source. So the polarity is positive, negative, and the resistor R, kita namakan dia, katakan A dengan B. RA dengan voltage source VA. So if you know that RA is equal to R3 and VA is equal to IP R3. So you ada idea dah apa nak buat. Okay, VA is equal to IP R3. Once you get that, so you can combine it with the voltage source VQ. Okay, VQ. Alright, VQ. So sama juga now. So now what you can do is that you combine VA and VQ. So kita namakan dia, katakan resistor ni RA. So kat sini kita ada VAQ. Okay. you can see that both of the polarity are equal, so you just add the two VAQ. So you have your RA is equal to R3 now. So we have that. So now what you can do is you transform this part into a current source and this part into a current source, and then you can combine the two current sources together, and you can find out V2 again using your VDR or whatever. Okay. So in this case, you tengok sini, you transform ni macam saya kata tadi, VB kita panggil dia B sebab we transform the first part of the left part of the voltage source VP dengan R1, you get the IARA, and then you transform the current source of R3 IP, which is basically what I've explained, only that the asynchronous use is different. So you have RBVB, so you combine together RBVQ. So once you have that, you transform the RB and VQ, okay, into RC and IC. With that, you can combine the IC and IA. And as I told you, apa ni kita, if you combine that, you can find the current and this one, current through I2 using current divided rule. I can find the V2. But for this case, you can see that V2, because RA2 dengan apa nama tu? Sekejap excuse me. Okay, sorry, ada clinic call. Alright, so you can see that what I want to explain tadi, between these two, the voltage are the same. Correct not? V2 is the voltage also across RC. So what you can do, kalau saya kata tadi tak boleh combine because RA2 is the one you want to find, but now you can combine because the voltage across it is the same. So V2, RA2 and RC can be combined together. So you can combine RA2C, you have RAC combination of the sources that you transform tadi, A dengan C. So you have a circuit there, looks like this, and you can find your V2 is the IAC multiplied by your RAC. So you have your V2 is IAC multiplied by RA2. Okay? Any question? Ada soalan? Patutnya kita minggu ni cuti kan? Minggu ke-8 Tasik?
Betul ke?
Habis
Betul.
cuti. Nak buat macam
Itulah.
tak apalah. Apa ni, lagi cepat. Habis nanti lagi cepat kita tu. Ya, tak apa. No problem. Ada yang menangis tu. Siapa yang menangis tu? Sebab tak ada cuti. Ada ibu menangis tu. Okay. Alright, I don't know kenapa dia orang buat macam itu. Saya pun minggu ketiga, minggu keempat ke baru saya perasan. Baru saya tahu yang tak ada cuti. Kalau tidak minggu ni.
Dr. Safi.
Pardon?
Ada limestone, Dr. Safi limestone reply dekat dalam chat.
Ya ke? Tak apa, nanti saya cek.
Okay.
Okay, apa nama? Any question? Actually, dekat ujung-ujung nanti minggu ke 10-11 nanti mungkin saya tidak ada. Lepas tu saya nak cuba habiskan syllabus. I have two options, sama ada saya apa ni, habiskan syllabus ataupun you can apa ni, saya nak cakap dengan the other two lecturers, maybe you can apa ni, join their class later. But I try my best so that you can get everything from me before you want to go to other class. Okay? So now you understand, very simple, okay? Superposition tadi apa kita buat? On satu, off lain. On satu, off lain. And then we sum up together. Voltage source, how you want to off it? Short circuit. You just draw a straight line. Okay? Current source, open circuit. You just throw away your wire that is dangling the open circuit kan. Right. So with that, once you do the analysis one by one, you sum it together. Just be careful on the polarity. Okay. Sama juga dengan current voltage source transformation tadi, source transformation. Voltage source in series with a resistor can be transformed into a current source in parallel with a resistor. The resistor in parallel for both resistor in parallel and in series for the current and voltage source are the same value. Okay, the resistor are always the same value, so you don't have to calculate anything because the resistor is the same value. Okay. So you can see that the resistor will always be the same value. Rs and Rs, only that it is in series with voltage source or in parallel with Is. So voltage source Vs transform from a current source, you use your basic Ohm's law, V is equal to IR. So in that case, Is multiplied by Rs. So you get your Vs. Sama juga, you want your Is from the Vs, voltage source, Vs and Rs. The Is, according to the Ohm's law, I is equal to V over R. So Vs over R. So straightforward. Okay. So now you can apply this source transformation or superposition. Okay, in what we're going to do now next is the in what we have something like this. Okay, katakan kita ada circuit kat sini. Okay, can you see the circuit 4.5, example 4.5? Hello?
Boleh.
Mana? Kuat sikit. Sebab saya takut apa ni, komputer ni saya ada problem, saya cakap nanti tidak dengar.
Yes, we can
Boleh,
see.
sir.
Boleh ya? Okay. So now you just imagine I give you this circuit. I ask you to find V3. Okay, tadi kita dah buat pakai source transformation. Of course, you can do the same question using superposition. You consider IS, you of VS, you consider VS, you of IS. So you can do that. But now, let's say you want to do something like this. You are designing a circuit, okay, where you want to vary the value of R3. Once if you want to vary the value of R3, let's say R3 memudahkan 8 kilo ohm. So what happen kalau R3 2 kilo ohm? What happen to the V3? Okay. What happen to the V1, V3 kalau R3 is some other value, some apa nama tu? Variable value 2, 4, 6, 8, 10, 12 and so on. Okay. When you that happen when you design a circuit, you want to find the current and so on. You want to limit the current here or the voltage here, so you can do. Okay, you have to vary the two. If you do your normal circuit, your normal calculation, what you need to do is you put the value, analyze the circuit. Kalau different value of resistor, put the value, analyze the circuit, and so on. Kalau ada value, okay lah. Kalau banyak value, so there is a need a mechanism that you need to do to simplify how you want to solve the solution, the problem. One thing is that you know that this is what, okay, let's say we call it R3 here. Okay, R3. So you want to find the current or the okay, you want to find the current I3, katakan sini. I3. Alright, go down here. Then or is it the V3? Okay. Across that resistor R3. R3. Okay. So with the value of R3 varies, your voltage V3 and I3 varies. So what you can do is that you can replace the circuit containing all the other element with a single voltage source. As you know, voltage source macam kita buat source transformation tadi must be in series dengan resistor. So we have a voltage source V in series with a resistor R. Or you can replace all the other, this one IS, R1, R2, R4 dengan VS ni dengan one single current source I dengan one resistor in parallel R. So ingat current source, resistor dia parallel, voltage source, the resistor in. Again, current source, the resistor in parallel, voltage source, the resistor in series. So this is the idea. So kalau you buat macam gini, so can you find the I3, whatever the value of R3 is? Because the R here, we fix it already by replacing all the other element with a single resistor, sama juga dengan current here. So you can use either the voltage source and resistor in series or current source in and resistor in parallel to find the I3 easily. Okay, in this case, I3 is equal to V divided by R plus R3. So whatever value R3, just tukar saja. Tukar, you can easily get the I3. Sama juga V3 kalau guna apa ni, PDR is equal to R3 divided by R over R plus R3 multiplied by your V and so on. So this is the idea of what we call, that we're going to learn later, Thevenin equivalent circuit with a voltage, with a Thevenin voltage VTH and a resistor, we call it Thevenin resistor. Okay. Or you can replace, if not with a voltage source, we replace it with a current source I. So it is called the Norton current. And then you have the resistor I R Norton. So you can see that V Thevenin, R Thevenin in series is equal to I Norton, R Norton in parallel. So basically these two, Thevenin to Norton, Norton Thevenin, is basically a source transformation. So this is the basic idea of Thevenin and Norton. You try to grasp the idea, and then that is what we're going to do the next chapter or the next part, which is the Thevenin theorem. The Thevenin theorem says that a linear two-circuit a linear two-terminal circuit can be replaced by equivalent circuit consisting of a voltage source VTH in series with a resistor RTH. So what is the VTH? Is the open circuit voltage at the terminal, and RTH is the equivalent resistance at the terminal when all the independent sources are off. Okay, I like to do the parallel in parallel because it's the same thing. Okay, Thevenin theorem, that is the theorem of the Thevenin, and the Norton. If you go back, dia ada contoh satu Thevenin dulu, but the Norton is the same thing also, equivalent circuit, current source, parallel, resistor Norton. IN is the short circuit current. Kalau voltage tadi open circuit voltage, because kalau short circuit voltage, voltage is 0, so you have to find open circuit voltage. Sama dengan current, current you cannot open because if you open, there is no current, so you have to find the short circuit current. And the RN or R Thevenin, either one is the equivalent resistance seen at the terminal when all the sources are turned off. Okay? This look very macam-macam. Memang macam-macam pun. Okay. So, apa nama? This is what we're going to do. I think we do tomorrow. You just get the idea of the superposition and source information first. Make sure you do all the tutorial, and then you try to do the all the example question. So that you really understand it, because you need to use that bila kita buat Thevenin dengan Norton tomorrow. Okay? Any question? Ada soalan?
Too many, sir.
Ha?
Too many questions today.
Ni buat tak ada orang.
Cakap ni nak ingat Taverny Norton je. A lot of information today.
Because this thing, macam saya kata, okay, you tanya je punya anakmu, apa ni cikgu baru tu lah. Okay?
Okay.
Macam mana dia boleh nak mengajar you? Okay, group 3,
Okay.
sekian. 16 baru, ada lagi. I will do my attendance, kadang-kadang awal, kadang-kadang tengah, kadang-kadang hujung. I just want to see you cabut dari kelas ni ke tidak. Yang ada seorang tak ada. Cepat. One of you is not here. Siapa yang tak ada ni? Okay, everybody here. So, group 4. So, kalau you tak ada soalan, okay, cuba buat. Okay. Jangan nanti last minute nanti baru nak tanya. Sebab ni dah makin banyak benda you kena faham, makin banyak you kena apply and so on. So, kalau you tidak buat daripada sekarang, memang I'm sure it will be very difficult for you to understand all the others later. Sebab lepas habis lesson 4 ni, you have 5 and 6, which is very easy. Okay. So before you come to that, you have to understand apa yang ada sekarang ni.
Chapter 5 and 6 easy tu betul ke sarcastic, sir?
Very easy, straightforward.
Like, really easy lah. Okay lah, boleh lah.
Sebab biasanya soalan tu 5 and 6 you have one question. Okay. Sekejap saya buat ni dulu. Okay. It is on op-amp and capacitor and inductor. The question boleh, okay, dapat. The question will always be, kalau series apa ni conductor, capacitor and inductor will always be series parallel, and you find the power and so on. Itu saja, tidak ada soalan lain lagi. Itu saja, balik-balik tu je. Tahun ni saya bagi capacitor, tahun depan saya bagi inductor. Sebagi ni, sebagi tu, bagi ni, bagi tu. Itu saja. Tidak ada nothing fancy. You need to find only what we call this one. Energy store, whatever. Okay, kat situ. Alright, for the op-amp, the simple op-amp, ada 5 combination, okay. 5 combination of different op-amp circuit. That is the ideal op-amp, the inverting, non-inverting, summing, difference, and cascade ada 5. So basically, I just cabut straw saja. yang mana satu saya nak bagi, soalan dia lebih kurang sama saja. So basically satu soalan tu 25 markah, combination of lesson 5 dengan lesson 6. Okay, there is no reason you cannot get the full mark over there, 25. So you need another 25 to pass. Okay, tengok betapa baiknya cikgu.
Betul, baik. Okay.
Okay, siapa lagi ni? Ni sama juga, orang yang sama juga. Fairly, Langston, Steven. Mana pergi? Mana tak tahu, tak apa nama tu? Scan. Okay. Mana you all? Okay. Kenapa tidak scan apa ni tu? Apa nama attendance ni? Okay, 3 orang ni. Okay, lain semua, you can go if you don't have anything. Okay. If you don't have any question, you can go.
Thank you, sir.